Very good evening, friends, and in this video we are going to discuss about the new concept called the interfaces. Java interfaces are the special kind of the classes which have final variables. Now the variables generally means the memory cells which have the value. They can be reassign values again and again, just like the normal mathematical variables which can have different type of values. Same way the Java variables are the memory containers where you can store the information again and again, and the previous informations will be overwritten. But here in this case, when we are introducing a variable and attach a keyword final, then it naturally becomes a constant. So now I declared one interface called calculation. It will have a constant. Constant means a memory cell which can store double type of values, and it has a value which cannot be changed. Like the here I declare double pi, and the pi is generally having the value 3.14. It is already present in the maths.py, but I want to use it in my own way. So I declare a variable called pi, and I store the value of math.py, and I attach the keyword final before it, so it becomes a constant. So I will use small pi as my variable, and it will have the value of that pi. And interfaces have abstract methods, the methods which are just declared. They do not have any body, they only have the name, parameter list, and the return type, like the int area. So it will return the int value, it will not take any value from outside. Now I make it double because if you are dealing with the pi, then the pi of that variable become circle, sphere, cone. So double. Now peri, so double is just perimeter or whatever it is, but it is also returning double type of values. And then I have another abstract method class, or class having abstract method definitely becomes the abstract. It is just a kind of abstract class, but we do not call it abstract class, we call it interfaces. Now it has a function void show, so four functions, no bodies, no definitions for these functions, only they have got the return time. Means these functions only specify what they can do, but how they will do it is not defined, and the class which inherit or implement this interface will have to redefine them so that they can use it for their purpose. Now I create one more class, and that class will be circle. Actually here we are using the simple common things, because those who are studying in 9-10, they understand these mathematical functions like the circle, cylinder, cone, etc. easily. So this is my class which has just one integer variable, that is the radius, r for radius, and this is the default constructor which doesn't take any values and sets r as 0, so that when an object created invoking this constructor will have the radius as 0. Now I just copy it and post it, and I make one more parameterized constructor, and its name is same, since it is constructor, but its argument have one integer value, and that value will be stored into the instance variable of the class circle. Now if this class implements those class, means the interface, those interface, so we do not write the, yeah, this is, since we are discussing the multiple inheritance, so I need another class, and this is, I create a class cone, and cone have the variable int h. Since we know that the variables important features of the cone are radius and the vertical height h, and there is a slant height also, cause slant height is making Pythagorean triplets, and find L is under root h square plus r square, because it makes a right angle triangle. So I create a constructor for this default constructors which will set the height to 0, radius and super. So this class cone is going to extend to the circle class. So it has to invoke the default constructor of the circle class also, and at the same time it has to set its height itself as 0. And now math.sqrt, or I can also say if r is 0, h is 0, so L is also 0. Automatically it will become 0. However, L is under root h square plus r square, so I write math.sqrt L into L, r into r, since it is using the radius from the circle class. But right now we have to extend it, we haven't done it. So r into r, and r will be connected to this when this class extends. And also keep this in your mind, if R is defined as a private variable in the previous class, then this cannot be accessed from here. So you have to make the radius variable public there if you want to access it from this class. So now I change the keyword and I make it public int R. So the R becomes a public instance and it can be accessed from a class which is going to inherit it right here in this case. So now everything is fine here, and I just try to see the basic structure of circle. Now I made the radius as public. So now you see I can access R because this class is going to extend that class. So the public feature of the circle class will be accessed easily from this class. And now I have to write the extend. So the cone extends circle and implements, it has to implement the calculation. So cone class is having two superclasses, circle and calculation, and this is called multiple inheritance. So with the help of interfaces, because you cannot have a class extends circle and extends this, because two extend statements are not allowed, because Java in this particular mechanism doesn't allow the multiple inheritance. So it is only indirectly achieved with the help of interfaces, and interfaces are those variables which have constant values and abstract methods. So they are just generally kind of abstract classes, because the variables cannot be accessed and reused because that is already constant, and the functions are simply declared, so they just going to tell you that they can do this particular thing. Signature is made there, but how that thing will be achieved is not defined, so it doesn't work that way. So now here I import the math function, because java.lang.maths, not maths, java.lang, and with that we are going to achieve our math sqrt function, and here it is. So now this class has, because we are discussing the multiple inheritance with the help of interfaces, so this class cone has to implement the interface calculation, and at the same time has to redefine all those variables which are abstract into the interface calculation. So now this is what we are going to have. Now again, this is causing a little syntactical error, because red lines are syntactical error, and when the program have the syntactical error, it cannot be compiled, and if it is not compiled, its object or bytecode will also not be created. So it has to be syntactically correct. So now this is what it is. So we are going to use sqrt function, or you can achieve it. There are various ways by one um, like thing can be done in the different ways, like slant height can be calculated this way, that way. It is just asking for, you have to input the double value, however integer. So I just introduce one double variable x, and it will be having the values as l in h into h plus r into r, but at the same time it has to be typecasted into the double, because these two are just going to give you. So now see, it's causing problem, because it is integer into sum of two integer cannot be double, it has to be typecasted into double. So I just typecast it. This is called the source variable, will be converted into the target variable. So this is no, it has to put inside the bracket. Okay, sorry for this, I have to change this one. Yes, so this h into r should be placed into the bracket, and then you have to write double without any bracket or kind, like just write like this. Yes, so just write double, and these are the various helps which come unnecessarily, but they are quite handy. So it is like this. sorry. So one more bracket is required, and yes, here it is. So now it is syntactically correct, and there are only some warnings there but not syntactical errors. So now we are going to implement those variables defined inside it, the calculation interface. So just you have to write the import this one. So implement, because they are, you don't have to write the extend word, you have to write the implement. So this is a constructor. I just try to, because this is a default constructor, I copy it, paste, and pass like integer r with the help of super, height, and cone. So radius and the edge. So the radius goes for the super class and the edge. So there should not be ambiguity. That's why I should make it HH. So I just better write it as HH. That way it's better, because H assigned into H is causing some ambiguity, and that is not a good thing for the programmer to have ambiguity in its code. So now I implement, so just implements calculation, and at the same time, since we are writing it on the IDE IntelliJ IDEA platform, this is a powerful IDE, like the interfacing, you can say the applications where you can write the program. These kind of softwares are called as integrated development IDE, integrated development environment. So when you create, when I implement it, then you see that this at the rate of overhead, these are called annotations. They just only say that these are the functions, these are overridden are the functions which are defined, redefined into the subclasses which are just declared into the superclass. So here I just defined all my functions, and this is just demonstrating the multiple inheritance. So this is how I just achieved this feat. And yes, r into r, and show function just is not required anything, because all these functions are returning values. So either I have to call these functions from here, or just I write something just for sake of showing, because this is just a program for the teaching purpose, not for any application designing. And so I can write anything into that, because I just want to demonstrate how it all works. So this is what it is, and then I'll be creating the object of, so the cone class is inheriting the circle class and implementing calculation class. This is called as multiple inheritance. So this is fine. These two lines are just useless, but I'm just writing just print something so that we can say that by redefining the function declared in the interface, we are trying to access the instance variables of this class, because the radius, height, and slant height are the variables of this class, and the show function has been declared in the calculation interface. So we are redefining the method, which is, and we are just redefining the abstract method, which is you can say declared into the interface and implemented into this class. So now it is done, this part. We only have to create the object of the class cone. Since we are going to achieve this with the help of data from the user, I'll to create the scanner class object, scanner sc equal to new scanner system.in, and you have to import this one. So you have just press alt enter from the IntelliJ IDEA platform users. For the NetBeans, I do not know what do they use there. Now this is in, so if you see on the top, this scanner class has been imported. So with the help of the system.print the radius of the cone, so I have to, this r and h are the static variables because they are declared inside a static class. So now these static variables will be encapsulated into the object of the cone, and that is the powerful feature of the object oriented programming called as data encapsulation. Data encapsulation. So object manifests the idea of data encapsulation. At the same time, they also promote the idea of data hiding. That is very important. So now here I just received the two values, radius and height of the cone from the user, from the console, and then I will encapsulate those values, static values, into the objects of the cone, and those values will initialize the instance variables of the cone class, and with the help of object we will be calling the functions defined in the cone class, and this is how the programming achieve its own feat. So now our sc dot next int, because we are expecting the integer values. So right now, since I am the programmer and I have to enter the values, just otherwise you have to use some try catch, because you do not know what the user can enter. And users are very dangerous and very important. Without user there is no program, and the user always love to break the program. So you have to make some more powerful validations and the secure system, so that user can enjoy at the same time cannot break your application. So now here I have received some values from the user, and I created the object cc for the cone. Cone cc equal to new cone r and h is passed. So now with the help of cc dot area, I can call cc dot area, cc dot peri, and cc dot whatever functions are defined in that class. With the help of cc we can call them all one by one, and this is how the program is designed. But one thing I would like to tell you, that in the real life applications very few, because console is not the way. The Java applications, Java swings are the desktop application designing tools, are the mostly the Java application receive the data from the port. They do not receive it from the console where the user give the data like that. So, but they can also do. So now I run the code, I see how it achieves the feat. So cc.show and all these functions I'm calling as running, and now here you see cc.show. Now it's running. Just wait for a second, and here it goes. So first it will ask the user to enter the radius and height, and then only it will display the result. So enter radius. I have to enter radius here, so I enter 23 and 45, and this is all slant height and all these things we have to. Thank you very much for watching this video. Just subscribe to our channel and keep writing something in the comment so that we can use it later. Have a very nice time.